Hey guys, welcome to day 19. Today's topic is the molar mass, but this time of compounds. Okay, so a lot of what we've been doing for the last several months is formula writing, and formula writing is going to be key because it is the formula of a compound that is going to allow you to calculate the molar mass of an individual molecule. Okay, so I'm going to just kind of zoom in real quick and do this one with you. So let's do sulfur trioxide together. Okay, so what we're going to need to do is we are going to need to look up the molar masses of sulfur. Now, if you look at the formula, there is no subscript for sulfur, so that indicates to me that there is one. So sulfur, if I look at the periodic table, it appears to be and I'm going to round to one decimal place. Today is 32.06, but today I'm just going to call it 32.1. So there is one sulfur atom in this formula, but there are three oxygen atoms. And oxygen is 15.9994, so I'm just going to call that 16.0, but there are three of them. So three oxygen atoms times 16 grams per mole per oxygen is going to be 48 grams per mole. So we're going to take these two numbers, we're going to add them together, the 32.1 plus the 48.0, and what we're going to end up with is the 80.1. And you can see that I have that down here. So one atom of sulfur is 32 grams per mole. Three atoms of oxygen would be 3 times 16 or 48. And then you're going to take the 32 plus the 48, and we are left with about 80.1 AMU. And then, we're going to simply swap out the grams per mole like we've always been doing. So if you guys want to dig into my notes here a little bit more, it does kind of go through individual steps, but simply starting with the formula, we can do that. So that was for a covalent compound. We can also do it for ionic. So calcium iodide, if I look up calcium on the periodic table, first of all, according to the formula, there is one calcium ion in this formula. So 1 times calcium would be, looking at the periodic table, 40.078. So I'm just going to call it 40.1. Okay, but we have two iodines, and I'll do iodine like that. So 2 times iodine. Now, iodine is kind of a heavy atom, about 126.9 grams per mole. So when you do 2 times 126.9, you end up with 253.8. So now what you're going to do is you're going to add together the 40.1 of the calcium plus the 2 times 126.9 or the 253, and what you're left with is 293.9 grams per mole. So 1 mole of calcium iodide, an ionic compound, would weigh 293, almost 294 grams. Okay, now of course, you're going to eventually use these numbers to convert grams of calcium iodide into moles, or maybe moles of sulfur trioxide into grams. So today we're just working on calculating molar masses, okay? Let's go ahead and look at some of the ones in your homework for today, okay? So CO2. All right, so it's got one carbon atom. So carbon is 12.01, and it's got two oxygens. So we're going to do 2 times 15.9994. And if we do that, we get 12.0 plus 32.0, and add them together, we're going to get about 44.0 grams per mole. Now you guys will notice that I am going to the 10th of a gram. I would like you guys to go to 2 decimal places, okay? I'm only going to 1 decimal place just to kind of keep things simple, okay? All right, let's do another one. Let's do sodium hydroxide. This is going to be ionic. So I see 1 atom of sodium. So 1 atom of sodium, according to the P table, is going to be 22.998. So I'm just going to call it 23.0 because I'm rounding to 1 decimal place. There is 1 atom of oxygen, 15.9994, rounds to 16. And there is 1 atom of hydrogen. So 1.008, I'm just going to call it 1.0. And when I add those all together, carry the 1, I get about 40.0, and don't forget the units. The units are going to be the gram per mole, okay? All right, so 40 grams per mole for sodium hydroxide, 44 grams per mole for carbon dioxide. Let's do one with parentheses. So strontium nitrate. So if I find strontium on the periodic table, it is atomic number 38, and strontium, there's one strontium atom. So one strontium is 87.6. 87.6. Now, we have a 2 outside the parentheses, so we're going to distribute the 2. So 2 nitrates would have 2 nitrogens, okay? And nitrogen being 14.007, I'm just going to call it 14.0. And I can do that math while I'm at it. 2 times 14 is 28, okay? All right, and if I distribute that 2, you're also going to notice that you have 6 oxygens. So 6 times 16, 15.9994 rounds to 16 would be, looks like 96. I'm going to check my math on that real quick. So 6 times 16 is 96, and that would be 96.0. Now, really the last step for us to do is we're going to have to just add up all these numbers. So the 96.0 plus the 28.0 plus the 87.6 leaves me with a number of 211.6. Don't forget the units. That's going to be the gram per mole. Guys, I am going to 1 decimal place. I would like you to go to 2 decimal places. All right, you'll notice at the bottom of the page that I didn't always give you the formulas, so it's just a chance for you to guys practice writing formulas. So dinitrogen tetrahydride, nitric acid, and calcium hydroxide, you guys are going to have to come up with the formulas first, and then you can look up the individual weights from the periodic table and then multiply them accordingly, okay? All right, so for number 2, I think we're going to save that one for another one. But I think we could probably do number 3, the molar mass of allyl sulfide, the compound responsible for the smell of garlic. The chemical formula is parentheses C3H5 and parentheses 2S. So when we dig into this a little bit, we have to distribute that too. So we're actually going to have 6 carbons, and 6 carbons would be 6 times 12.01. Okay, we're actually going to have 5 times 2, or 2 times 5 hydrogens. So we're going to have 10 hydrogens, and hydrogen is 1.008. So we're just going to do 10 times 1. And it looks like we're just going to have 1 sulfur, and sulfur is just going to be 1 times 32.1. And I can show my math here. So 6 times 12 is, I believe, 72. 1 times 10 is 10. And 1 times 32.1 is 32.1. Now, guys, quick note about sig figs. Don't let the number of atoms limit your sig figs, because these are exact numbers. So you're going to usually go to 2 decimal places, which means your answer is going to be rounded to 2 decimal places. I know in my example, I'm only going to 1. So really the last step for us to do is add up the 72.0 plus 10.0 plus 32.1, and it looks like the molar mass of allyl sulfide is about 114.1 grams per mole. Granted, guys, I could have made a mistake, but I think the process is pretty straightforward. Parentheses can add a slight level of difficulty, but it's not terribly hard. So today I want you guys to practice calculating molar masses, and then the next time that we meet, I'm going to have you guys converting between grams and moles using the molar masses of compounds. All right, guys, if you have any questions, you can email me. You can send me a message on Google Classroom. I miss you guys. I love you guys. I hope to see you soon.